Namaskaram. In last class, we have seen the concept of double integration. In this session, we will see how to evaluate double integration over a rectangular region using iterated single integrals. Okay, consider the problem. Evaluate integral 1 to 3, integral 2 to 4, 40 minus 2xy dy dx. This is called iterated integrals. That means first you have to evaluate this portion. That means you integrate this 40 minus 2xy with respect to y by keeping x as a constant. Then you perform the next integration with respect to x. Okay, so I will explain. So this is equal to integral 1 to 3 and dx. And what about this integration? What is the integration of 40 minus 2xy with respect to y? 40 become 40y minus, here 2x is a constant. Clear? So 2x into y square by 2. This is the rule. And our 2 to 4. This is the idea. Then you can substitute the upper limit and lower limit. Then what happened? Okay, you can cancel these two and substitute 4 for y. So this become 160 minus 16x minus the lower limit is 2 and y equal to, this is 80, and 80 minus this become 4x. Okay, then this we can simplify this expression. So this become 1 to 3, 80 minus 12x, right? 80 minus 12x dx. Then you can perform the second integration with respect to x. So this become, so 80x minus 12x square by 2, you can cancel, this becomes 6. Then by substituting upper limit and lower limit, so this become 112. Okay, yes, answer is 112. Next we consider the same problem, 40 minus 2xy. Only difference is we change the order of integration. Okay, here we first integrate with respect to x from 1 to 3, then we with respect to y. And what is the corresponding change in this integration? Okay, you can easily integrate in same fashion. That means first you integrate with respect to x by treating y as a constant. Okay, this is 40x minus 2x square by 2y, because we can treat y as a constant. Clear? And you can cancel these two and substitute the upper limit and lower limit for x. So like this, again you can simplify this inside function. So this is 80 minus 8y dy 2 to 4. Then next we have to integrate this with respect to y. So 80y minus 8y square by 2. So this becomes 4. Then you substitute upper limit and lower limit. Again this is equal to 112. The same answer. Clear? So both gives same answer. Okay. Why they are same? We will analyze this geometrically. Okay, first we are going to analyze what is the meaning of the first integration. Okay, and we know that here we fix x because here the variable is y, so we fix x as a constant. So we can treat this function 40 minus 2xy as a function of y alone because we fix x at some point. Okay, only moving part is y. So we can treat this function 40 minus 2xy as a function of y alone, z equal to f of y. Then we know that in the zy plane, you can think z equal to fy as a curve like this. Okay, and what is the meaning of integral f of y dy? This is nothing, it is the area between the curve. Okay, so my question, what is our curve z is equal to 40 minus 2xy if we fix x? So if you fix x somewhere here, then it is clear that this z is equal to 40 minus 2xy is a part of the surface, this part of the surface at this particular x. So that is nothing, this curve. Okay, this curve on the surface. So next we integrate this curve from 2 to 4, right? Next we integrate this curve from 2 to 4. So geometrically we know that the integral of a function from some point to some point is nothing, it is the area between the curve and the axis. So here instead of the axis, here the area, this area of this blue region. Clear? So the interpretation of this first integration is nothing, it is the area of this blue region, right? That is nothing, 80 minus 12x, because this area depends x. Suppose x is somewhere here, then area is smaller than this area. So that's why area depends x. Next, we are going to integrate 1 to 3 this area dx. Area means here 80 minus 12x. That means we are going to add all such areas. Clear? This is the integration, means it's a summation, infinite sum. So area corresponding to this x, area corresponding to this x. You think about all the areas corresponding to all the x's. Then you take the sum of all areas. That is the meaning of volume, right? Summation of area. So next we are going to integrate, or we are going to sum all such areas from 1 to 3. That is this integration. So this integration gives what? 1 to 3, 80 minus 12x dx. This is nothing. This is the volume of this solid. Clear? So this is the interpretation of this double integration. Similarly, you can interpret our other integral. How? First we integrate with respect to x by fixing y. So we fix y somewhere here. We fix somewhere y means our surface z is equal to 40 minus 2x. So we become a curve on the surface. That's all, because we fix y equal to suppose 3. Then it is a curve like this at 3. That's all. Okay. Then we integrate that curve with respect to x in the x direction. Right, in the x direction from 1 to 3. So that is gives this yellow shaded area. Then, so this is our area in terms of y, because area depends y. If you choose another y, then what happened? Area is different. Here area is different. Okay. Next we sum up all such areas in y direction. That is integral 2 to 4. Integral 2 to 4 area. So that is nothing, the volume of the same solid. That's why in both cases the integration gives 1, 1, 2. Because that is nothing, this integration nothing, it is the volume of that same solid. Clear? Suppose this rectangular region is denoted by R. Then we know that the volume is denoted by double integral over R fxy dA. So now we have an iterative formulas for evaluating such double integral. That means if the region is rectangular, then we can evaluate these type of double integrations using these type of iterative integrals. Okay, that means we know the volume, we can evaluate the volume using this formula, and we denote this formula using, this is the notation, and now it is clear that we can evaluate these type of integrations using iterative integrals of single integrals if the region is rectangular. So that's the result. If R is a region, okay, that means R is a rectangular region defined by these two inequalities. That means x is varying from a to b and y is varying from c to d. It is clear that it is a rectangular region. Okay. Then the double integral over such rectangular regions f of xy dA is equal to, we can use any of this formula, any of this iterative integration. A to b, c to d, f of xy, dy dx. Here c to d is the range of y, right? That's why first we integrate with respect to y, then x. Or you can use this formula. You can interchange the integration. Integral c to d, integral a to b f of xy dx dy. Here we integrate with respect to x. First we integrate with respect to x. That's why here the limit is a to b, because x is varying from a to b. Clear? That means we can evaluate these type of double integrations using these type of iterative integrals if the region is rectangular, because this formula is almost impossible to evaluate. Okay, consider a problem. Find the volume of the solid that is bounded above by the plane z is equal to 4 minus x minus y, and below by the rectangle 0, 1 cross 0, 2. That means x is varying from 0 to 1 and y is varying from 0 to 2. Okay, so this is the geometrical representation of this problem. Okay, so x-axis, y-axis, z-axis. So x is varying from 0 to 1 and y is varying from 0 to 2, and z is equal to 4 minus x minus y is a plane like this, a slanted plane. We have to find the volume of this solid. Okay, so it is clear that it is the region is rectangular, so you can use our double integration. What is the formula? Okay, we know the volume is equal to double integral over R fxy dA, and this region is rectangular. We can evaluate this double integral using iterative integration. Okay, so I am going to use the order dx dy. So first you integrate with respect to x, then with respect to y. So what is the change of x in this rectangle? It is clear that in this rectangle x is varying from 0 to 1, right? So this limit is 0 to 1. And what is the change of y? Y is varying from 0 to 2. Clear? So this is the change of y, 0 to 2. And what is our function? Function is z is equal to fxy. That is given. Okay, function is z is equal to fxy. So this is 4 minus x minus y. So if you compute this integration, that gives the volume. So first we have to evaluate the first integration. That means we evaluate with respect to x by keeping y as a constant. That's all. Okay, this is equal to 0 to 2. This become integration with respect to x. So 4x minus x square by 2 minus y is a constant. So this become xy and 0 to 1. You can substitute 1 and 0 for x and simplify. So this expression become 7 by 2 minus y. That means 0 to 2, 7 by 2 minus y dy. Next you have to integrate this with respect to y. So what happened? Okay, this becomes 7 by 2 y minus y square by 2. Then you can substitute the upper limit. That means 10 by 2 into 2 minus this is 4 by 2 minus when y equal to 0, this time is 0 minus 0. So upon simplification, this becomes 5. Yes, the answer is 5. Okay. Next problem, evaluate the double integral over r y square x dA over this rectangle. Okay, so now we can easily set up this integration. That means double integral over r y square x dA. Okay, you can integrate in any order. So I am going to integrate in this order dx dy. So first you have to set up the limit of x. X is varying from minus 3 to 2 and y is varying from 0 to 1. What is our function? Function is y square x. That's all. Okay. Then first we evaluate this portion, integrate with respect to x, keeping y as a constant. Okay, this become y square into x square by 2 and minus 3 to 2, substituting upper limit and lower limit and simplify. Become minus y by 2 y square dy. Next we integrate with respect to y. So this become minus 5 by 2 and what is y square? Y square is y cube by 3 and limit is 0 to 1. Next we substitute the upper limit and the lower limit. So this expression and its value is minus 5 by 6. Right. So here this double integration is negative. Yes, answer is minus 5 by 6. Okay, is it true? Is it possible a double integration is negative? Or why it is negative? Yes, it is possible to negative. Why? Because we know that double integration is actually an infinite sum. And in this infinite sum contains a term like this, f of x k star y k star. And in sometimes this function, this value may be negative. Clear? So corresponding to this negative f values, this gives a negative, like a negative volume. Okay, so that's why this is negative. For example, in this function, you can plot the surface. Actually, this is the shape of this plot. Okay, so corresponding to this height, here our z is positive, right? So corresponding to this portion, the volume is positive, right? Corresponding to this portion, that means this rectangle, corresponding to this rectangular portion, here the functions are always negative. So it gives a negative volume. Okay, so what about the meaning of this minus 5 by 6? The meaning of minus 5 by 6, it is the difference between these two volumes, and this minus I indicates that the negative part is greater than the positive part. That's all. Okay, or we can interpret this double integration as net signed volume, net signed volume of the surface and the plane. Okay, so this is your homework. Thank you.